students. Today we are going to discuss very important topic in organic chemistry because organic compounds exist in different structures. This property of organic compounds is essential for study of organic compounds, for their separations, study of different behavior due to this property, but they have same formula. Molecular formula is same, but the structures are different. Structural arrangement of atoms and groups are different, but having same molecular formula. So this type of compounds are called isomers, and the phenomenon is called isomerism. So isomerism means it is a phenomenon of forming two or more structures having same molecular formula. Phenomenon of forming two or more structures having same molecular formula is called isomerism. And each compounds are called isomers. Compounds are called isomers. Compounds are called isomers, and the phenomenon is called isomerism. Same molecular formula but different structures. Isomerism generally two types. One is structural isomerism or structural isomers, and the second one is stereoisomers. These two isomers, structural isomers and stereoisomers. Structural isomers results due to arrangement of atoms and groups in the molecule, but stereoisomer observed due to differing spatial arrangement of groups. Differing spatial arrangement of groups. Differ in what? Spatial arrangement of groups. Atoms and groups will be rearranged in the space. That's why that is called stereoisomers. But the structural isomers only the differing arrangement within the molecule. We can say it is two-dimensional. In two-dimensional arrangement, that is called structural isomerism, and three-dimensional arrangement that is called your stereoisomerism. We can say in this way, and here atoms and molecule will be rearranged, and here also atoms and molecule will be rearranged but in space, 3D space. So this is the difference between structural isomers and stereoisomers. And types of structural isomers, let us discuss types of structural isomers. First part is chain isomer. Chain isomers means they differ in carbon chain. For example, this is N-butane, but it can be written as CH3, CH. This is called 1, 2, 3, 2-methyl propane. Both having same molecular formula, that is C4H10. Same molecular formula but different structure. It is a straight chain, it is a branch chain. So chain is different. But chain isomer also can be written as ring chain isomers. that it is also one part. Second is ring chain isomers. In ring chain isomers, the different ring chain. For example, you take CH3, CH, double bond, CH2. This is called propene. It is a open chain compound. And this one, if you see, this is cyclopropane. Cyclopropane. So cyclopropane and propene having molecular formula C3H6. Molecular formula is same, C3H6. It is open chain, it is closed chain. So ring chain isomers is possible. Open chain isomer also possible. In case of open chain, only they differ in branching. But in ring chain isomer, the differing that cyclic and open chain. Open chain will be a cyclic form, but having same molecular formula, that is called ring chain isomers. Then second is position isomer. In position isomer, the differing position of functional group. For example, CH2, double bond CH, single bond CH2, CH3. This is one butene. This is one butene. 1, 2, 3, 4. So this is one butene, and it can also written as CH3, CH, double bond CH, and CH3. 1, 2, 3, 4. That is 2 butene. So one butene and 2 butene, they differ in what? Position of same functional group. One position, it is 2 position. That's why it is called position isomers. Okay. Then third one is functional isomers. In functional isomer, the differing functional group. Formula is same, but the differing functional group. For example, CH3, CH2, OH. This is ethanol. Here functional group is alcohol, but it can be written as CH3, O, CH3. This is your methoxy, methane. It is ether. So this class compound is ether, this class compound is alcohol, but having same molecular formula, that is C2H6O. C2H6O. Formula is same, but functional group are different. Or other example you can also take CH3, COOH, and it can be written as HCOOCH3. Here molecular formula is, this is called acetic acid, and this is methyl formate. So if you see the formula C2H4O2, here C2H4O2, formula is same, C2H4O2. Formula same but different functional group. Here this is the functional group is acid group, here functional group is ester group. So the differing functional group but having same molecular formula, that's why these are called functional isomers. Then metamorphs. Metamorphs means the differing alkyl group around the same functional group. Functional group will be same but the differing alkyl group. For example, the differing alkyl group means you can write also before in alkyl group C2H5O, C2H5. This is called as ethoxy ethane. This is called ethoxyethane. And this other example you can take like this: CH3OC3H7. Formula is same, C4. Formula is C4H10O. This is the molecular formula. This is also same, C3, C4 and H10O. But this is called ethoxyethane and this is called methoxypropane. Methoxypropane. This is the IPC name. So these are called metamers. Other example also you can write like this: CH3, CH2, NH, then C2H5 can be also written as CH3, NH, C3H7. So it is diethylamine. This is propyl methylamine. So this it is, and last one, both are metamers, because they differ in alkyl group. Here alkyl group is methyl. Here alkyl group is here alkyl group is ethyl. Here alkyl group is methyl and propyl. So that they differ in what? Alkyl group. That's why these are called metamers. Then what is tautomers? Tautomers, these are the functional isomers. Functional isomers exist in dynamic equilibrium. That means formula is same, but the differing functional group, and they also exist in dynamic. That means they can be interconvertible. That means, for examples, you can take that CH3CHO. This compound exists in dynamic equilibrium. This is possible by shifting of hydrogen from one carbon to another functional group, CH, and become double bond, then CHO become OH. Formula is same, that is C2H4O, C2CH2. C2H4O, it is also C2H4O. What is the difference? Here difference is, here aldehyde group, here is En and all. Here particularly this type of isomers is called also ketoenol form. Keto and enol form, and this is your keto form and this is your enol form. Enol means, what is the meaning of enol? Enol means double bond and OH, and keto means keto group, only keto group is there. So it is, these two examples are called tautomers. Here it is enol form and keto form, but keto form is more stable than enol form. Stability, because keto form has C double bond O, that is stronger pi bond, but in enol form has CC double bond, that is weak pi bond compared to C double bond O. That's why a strong C double bond O, that's why it is more stable than enol form. And the percentage of enol will vary. It depends upon the parent's compound taken. The stability of enol depends upon the structures. For another example, you can take CH3, CO, CH3 exist in dynamic equilibrium. Same, you shift hydrogen from one carbon to next functional group. CH2 double bond, OH, then CH3. Okay, same shifting of hydrogen from one carbon to next functional group. Here CH3 from CH3 H will be shifted to oxygen. That is called hydride shift. You can say it is called hydride shift. Hydrogen shift, you can say it is keto form. and this is enol form. Enol form, enol means double bond and OH group must be there. And another keto-enol form, if you take diketone, in diketone also what happens? Same equilibrium exists. Here you shift, suppose you shift hydrogen from here, it becomes CH3, CH2, double bond, COH, then CH2, CO double bond O, then CH3. Here you see, here what happens? Shifting of hydrogen from this position to oxygen, or it can be done shifting of carbon these to OH, also possible. It is also possible in this way. Another form also possible like this: CH3, COH, then double bond CH, then C double bond O, then CH. It is also possible. So this is also one enol form, this is also one enol form, but compared to this enol form is more stable due to intramolecular hydrogen bonding. The hydrogen bond will take place in OH group and keto group, remaining keto group. Here such type of hydrogen bonding is not possible. That's why as intramolecular hydrogen bond is exist between this, or this form is more stable due to by other concept. But here the concept, remember, intramolecular hydrogen bonding. That's why this enol form is more stable than previous one. If you compare this stability, that this form is least stable and this form also least stable, but this term is more stable. It is more stable. More stable. So this is regarding different types of structural isomers. That is chain isomer and position isomer, functional isomers, and your ring chain isomers, then metamorphs, then tautomers. And in between tautomers, that is keto form and enol form. And keto form is more stable than enol form because keto form has stronger C double bond O, that is stronger pi bond, but enol has weak pi bond, CC pi bond. And if the enol form is stabilized by, if enol form has intramolecular hydrogen bonding, stability is more. That's why the percentage of enol depends upon the stability of enol form. If stability is more, then percentage of enol form will be more. So this form exists in dynamic equilibrium. That means two form, some form, keto form exists in more percentage in compared to enol form, but percentage of enol form differ with different structures. So these are the different types of structural isomers, and in practice it is very important for your examination. Okay, thank you.